Okay, good day. So today we will be discussing about atoms. Okay. Now, when we say atoms, these are the basic unit of matter and defining structure of an element. Now, the term atom comes from a Greek word. Now, the Greek word is atomos, which means indivisible. Okay, because before it was thought that atoms were the smallest particle, but after years, it was discovered that atoms are composed of different particles, which we call the subatomic particles, which are the proton, neutron, and electron. Okay. Now this one is a basic structure of an atom. So we have here at the center, we have here the nucleus. Okay. Now the nucleus composed of protons and neutrons, and surrounding the nucleus is the electron. Okay. Now this table will show some of the information regarding the subatomic particles of atom. Okay. So for particles, so uh, for the entire duration of the class, we will be using P, this symbol, for proton, and for neutron, we will be using this symbol, and for electron is this symbol. Okay. Now, on the next column, we have the charge. Okay. Now, C here stands for coulomb. Okay. Now, coulomb is a unit for charge. Okay. Now, for proton, we have plus 1.602 times 10 to the negative 19. For neutron, we have 0. And for electron, we have negative 1.602 times 10 to the negative 19. Okay. Now, as you can see here, for proton and electron, they have the same value, or they have the same magnitude. Okay. That's why, relative to each other, we can say that the charge of proton is positive 1. Okay. For neutron, it is 0, and for electron, it is negative 1. Okay. Now again, this is what you call the relative charge. Okay. So when we say again relative charge, for example, for proton, it is the charge relative, let's say, to electron. So we can say that it's positive 1. And for electron, let's say, for the charge of electron relative to proton, it is negative 1. Okay. But for proton relative to itself is positive 1. Okay. Now for neutron relative to proton, it is 0. Okay. Now on the third column, we have the masses of these particles. Okay. So for the proton, we have 1.67 times 10 to the negative 27 kilogram. For neutron, we have 1.67 times 10 to the negative 27 kilogram. And for electron, we have 9.11 times 10 to the negative 31. Okay. Now, as you can see here, take note of this one. Electron, it is times 10 to the negative 31. So we can say that this one is a very small compared to proton and neutron. Okay. That's why these two, the mass of proton and the mass of neutron, contributes to the mass of an atom. Okay. Although this one contributes to the mass of the atom, but since the magnitude is very small, okay, the one that contributes more to the mass of an atom is it's the proton and the neutron. Okay. Now, since we have an idea of what is the charge, the mass, and the data regarding the subatomic particle, we can now go to the atomic symbol. Okay. Now for atomic symbols, so let's have an example here. So we have here beryllium, and you can see here some numbers 9 and 4. Okay. Now this Be here, okay, stands for the chemical symbol. Okay. Now this one, okay, is the mass number. Okay. Now for mass number, we will designate this as A. Okay. And also A is used for mass number in some textbook. So we can say that this is A. And this one is your atomic number. Now atomic number in books, it is used, we use Z. Okay. So this one is your atomic number. Okay. Now, when we say, now how do we use these numbers here? Now for atomic number, so when we say atomic number Z, it is equal to the number of proton. Okay. So meaning for beryllium, okay, the number of proton now is equal to 4. Okay. Now, for a neutral atom, okay, so when we say neutral atom, meaning it doesn't have any charge, okay? So when we say it doesn't have any charge, so it doesn't have any excess electron or less proton, okay? So meaning it's neutral. So when we say neutral, the charge is 0. So we can say now that Z is also equal to the number of electron, okay? So in this case, the number of electron is equal to 4, okay? Now the next one is the mass number, okay? So when we say mass number A, this is equal to the number of proton plus the number of neutron, okay? Now for the number of proton, now we know the number of proton based on the atomic number, okay? Now for example, for beryllium, the mass number is 9, which is equal now to 4 plus the number of neutron, okay? So therefore, number of neutron is equal to 9 minus 4, which is equal now to 5, okay? So meaning for beryllium, the number of proton is 4, the number of electron is 4, and the number of neutron is 5, okay? Now, let's go now to another example here. We have the xenon, okay? Now, as you can see here, it has a different format compared to beryllium, okay? Now, this one comes from the periodic table of elements, okay? Now, this one is the chemical symbol. This one is the chemical name, okay? Now, where can we see the atomic number, okay? Now, this one is your atomic number. So meaning Z is equal to 54, okay? So meaning the number of proton now is equal to 54, okay? And for a neutral atom, we can say that the number of electron is also equal to 54, okay? Now, where is the mass number? Okay, now the mass number is, we can see it here, okay? Now this one is the atomic mass, okay? Now when we say atomic mass, it is the combination of the masses of proton, neutron, and electron, okay? Now since we have emphasized in our previous discussion that electron has a very small mass, so the one that contributes to the mass of an atom is the proton and neutron, okay? Now, To get the mass number from the atomic mass, what we can do is we're just going to round this off to the nearest whole number. So meaning our Z here, or sorry, our A is equal to 131. Okay, which is equal to number of proton plus number of neutron. Okay, so we have now 131 equals 54 plus the number of neutron. So number of neutron now is equal to 131 minus 54. Then the number of neutron now is equal to 7. Okay, so yes, that's it for our lesson today. Okay, on our next video, we will be discussing how to get the number of proton, electron, and neutron if we have charged particles, or charged atom. Okay, so again, when we say charged atom, it has excess or less electron. And also we will be discussing how to get the number of proton, electron, and neutron for isotopes.